All right, here is our practice quiz. I'm going to walk through all our different types of problems. Hopefully this might answer some questions that have been lingering over the homework. So if we look at the first problem, you will notice how we have to find f, and then we pronounce that composed g. So another way to write that would be f, open parenthesis g, open parenthesis x, parenthesis, parenthesis. What that means is we're taking f, we're getting rid of x, and plugging g in for that. So what this is going to look like, we're going to do f of g of x, so f of 3 times the square root of x, which means we take the square root of 3 times the square root of x, put that inside parentheses, and finish out the rest of the function. So here that means we have this power on the outside, which when we remember how we simplify with powers, we have to distribute that to every piece of the term on the inside. So that turns into 9, and then the square root of x times, well, not the square root of x squared, is just x. So we get 9x minus 4. So that's our answer there, and that's all we have to do. If we look at number 2, we have h parenthesis j parenthesis x parenthesis parenthesis. So we would say that h of j of x, or we can say h composed j. So again, we are plugging something into h, and what we're plugging in is this whole piece right here. So we take h, which is 5 times x, but in actuality, we're doing 5 times everything that is j, which is 1/2 of x plus 4, and then our last piece, which is minus 7. So let's distribute with multiplication. We just distribute it once to a like term, so we get 5/2 times x plus 4 minus 7. I still see parentheses, which means it is not simplified, so we now have to distribute that. When we're distributing across addition, we have to do it to each term. So we get 5x divided by 2, but when we distribute 5/2 to positive 4, stuff can cancel out, so we end up just getting 10 minus 7. So again, we can clean this up because we have like terms. So we get 5x over 2 plus 3. So that is composition. That's when we take two functions and create a third new one by composing. Decomposition, or decomposing, is when we look at a function and we try to see where could there be two obvious functions here. Whenever you see the radical, or like if you see parentheses squared, or you see a rational function with something on the top versus the bottom, that is a candidate. Whenever you see parentheses, or in our case here, the radical, one easy way would be to say f of x is equal to the thing inside the parentheses, and g of x would be the thing where if we just scribbled that all out. So we do 3 times the square root of x plus 1. We can do all sorts of different combinations here. So another one could be f of x equals the square root of x minus 7 over 2, and g of x is equal to 3x plus 1. Wherever we could just take a big hunk of the function out would be however we can compose. So I'm not going to get into all the possibilities because they are quite lengthy, but here are two different options for number 3. Moving on to number 4, right? So we're moving on. 1, 2, and 3 were all from 8.1, and now we're moving on to 8.2, which is all about inverses. We had a lot of different explanations for what an inverse is. The first thing was if we had a coordinate point, our inverse, right? So if this is f, our inverse, which is notated as that, looks like a power of -1, it changes into xy. So we can say the x swaps out with the y, they change. We can say domain changes with the range, right? Graphically, if we have a function, let's just say a parabola, we would say the inverse is when we reflect that across the line y equals x. So the inverse of a graph is if we reflect it across the line y equals x. So we have coordinate points, we have just the values, we have domain versus range, we have a graph. If we had a table, right, if this is f, then f inverse would look like if the y went first, but we'd still call that first column x. And then lastly, if we have an equation, let's say y equals 2x plus 1, when we find the inverse, if that's f of x here, when we find the inverse of x, what we do is we swap the variable itself. And then we clean up. And then to find the inverse, we clean it up and get y by itself. So here we get x minus 1 over 2. So a lot of different explanations here. Choose one, be ready to explain it, but hopefully you understand all the different explanations. Next up, we actually have to find an inverse, and here it says find the inverse of g of x. So here is g of x. All right, and as I did in class, I will always change color when finding the inverse. But the first thing I do is get rid of that function notation because it can be confusing, and just write it in normal notation. So, as we said here, right, when we find the inverse, we actually have to switch where our variables are. We're not done. Technically, this is the inverse now, but we're not done. That's not a normal equation that we want to see. So we have to start trying to solve for y. So the first thing we do is divide by 3. So we get x divided by 3 equals the square root of y. And then we want to get rid of that square root. So the only way to get rid of a square root is to square it. So we have to square both sides. When we do that, we get x squared on the top, because again, we have to distribute that power. 9 on the bottom. These cancel out, so we're just left with y. The rest of this is just got to clean up. I like my y on the left, so should you. And then lastly, we are asking to find the inverse of g, so we should write that in that notation. The inverse of g of x is equal to x squared over 9. All right, so that's how we find the inverse. The next question is going to ask to verify that these two are inverses. The only way to verify is to take m of n of x, and we want to see if that's equal to x, and then we have to take n of m of x and see if that's equal to x. That's the only way to verify. Graphs could be a little bit deceiving, so please check this algebraically. So if we do m of n of x, we're doing m of x plus 4 squared on top of 2. Oops, sorry, I wrote that wrong. Minus 7. So what that means for our function is we plug it in, we get 2 square root of x plus 4 over 2 squared minus 7 plus 7 still inside the radical house, minus 4 all the way on the outside. We should have stuff that cleans up. The one on your quiz might not be an inverse, so you might have to be careful here. All right, the square and the square root cancel. The divide by 2 and the multiply by 2 cancel. The add 4 minus 4 cancel. So we get x at the end, and that is what we wanted. We have to check if we compose it in the opposite way if we still get x, because what we need to remember is we need to compose in the proper direction because we can get different answers. So again, we take n and we want to plug in m, which is 2 times the square root of x plus 7 minus 4. So that means we take n. Wherever we see x, we have to plug in this whole function. So that's going to be 2 times the square root of x minus 7, x plus 7, minus 4, plus 4, all divided by 2, squared, minus 7. So again, stuff starts undoing itself. We're hoping that it continues on, and it cleans up pretty well. The 2's divide out, so we get the square root of x plus 7 squared minus 7. The square root and the square cancel out, so we get x plus 7 minus 7. So we do end up getting x at the end, so we're good. So this is verified because we showed if we compose them both ways, we get x. So now on the back, we're going to work on 30.1 through 30.3. So this is all about parametric functions. The first question asks, I just want to see if you understand what parametric functions are. So I gave you the set of parametric functions, and I want you to fill out the table. So what that means is take the 0, plug it in. So we do 10 minus 0 to get 10 for x, and then plug that in for t for y, and we get 0. So we can just graph it right away. We go to 10, 0, that's our first point. Plug in 1, 10 minus 1 is 9. 3 times 1 is 3. So 9, 3. Do that again for 2, if t is equal to 2. That's 8 for x, but then if we do 3 times 2, we get 6. So 8 and then 6. And then lastly, for t is equal to 3, we do 10 minus 3, which is 7. 3 times 3, which is 9, so we can go to 7, 9, and we get this function, which once we graph the connection, assume the pattern is going to go on that way, we can see that it's going to be a linear function. So the next question is actually going to ask, let's find the rectangular function. That's just y equals mx plus b in this case. So our two functions that we have is x of t is equal to 10 minus t. Y of t is equal to 3t. We want to get rid of t just so we have y on one side and then x and some numbers on the other side. So we can clean these up. We don't really have to write this part right here. We can just say x equals 10 minus t and y equals 3t. What's always easiest is to take our x and solve it for t. Right, so we can subtract 10 on both sides to get x minus 10 equals negative t divided by negative 1. So we get x divided by negative 1, which is negative x. Negative 10 divided by negative 1, which is positive 10, equals t. So then what we do next is plug it back into y. So we have y equals 3t. So we plug it in for t. So we get minus x plus 10, where t used to be. And then we can distribute that to get y equals negative 3x plus 30. If we tried to compare our graph to that, we could do that in our graphing calculator and see if they match up. It's kind of hard here because then 30 is all the way up here, and it's hard to see it on the graph that I gave you. So one way to check it would be to plug in 10 and see if we get the same y that we did in our table. Yep, and we got the 0 that we said we did with our table. Next, this is a new, we're not caring about 7 or 8 now, we're looking at this new pair of functions. We have one parametric, and the rectangular function, we want to find the other parametric. This one is the one in class that I said was the easy one, because we have x, and we just want to substitute it in for the x that we have in a rectangular. So that means we take our y, which is negative 2x minus 1, and we substitute in that whole thing that we know is equal to x. So again, we have to distribute. So we get y is equal to negative 6t plus 8 minus 1. So we get y is equal to negative 6t plus 7. So that would be not just y, but that would be y of t, because we're putting y into terms of t. So t is our independent variable, y is our dependent variable. This one was the one in class that we really did too much work on, and then at the end we found an easier way. So here we see y by itself, and then y of t, which we can just rewrite as y by itself. So what we can do here is set our two y's equal to each other. So our first y is 2x plus 5, and we can set that equal to our second y, which is 4t minus 1. So then what we want to do is to get x by itself on the left, so we can start moving stuff over to the right. So we get 2x is equal to 4t minus 6, divide everything by 2, so we get x is equal to 4t divided by 2, which is 2t, negative 6 divided by 2, which is negative 3. So again, that's x, but we can rewrite it into function notation of x of t is our answer. So that is it for the practice quiz. The quiz on Tuesday will look like this, but remember you have a group quiz, so you can expect to have different problems from your neighbor, but similar enough problems where you can all help each other, because all of the steps are all the same, all of the solving methods are all the same, but you will have to look at their problem and see how to talk to them, not just show them your answer. So good luck, and let me know. Stop by seminar on Tuesday morning if you have any more questions.